Welcome back to Element 14 Presents. I'm Clem, and this tool has saved so many projects. Do you even see it? It's right over here. And guess what? I made it myself. This is the Blooper, the USB Looper. It's like a null-modem cable, but for modern devices. That's a bit hard to explain. Let me show it to you. Follow me to the computer. Welcome to my computer. So I have my Blooper here. I've plugged in two USB-C cables, and the other ends are now plugging into the computer you see in front of you. Let's see if they're both there. LS USB, and I can see them. Yeah. You can see these two devices. These are basically, the Blooper appears as two independent devices, and FTDI, that's the FTDI chip on there. So let's do the log file thing. What I need is, I need to connect to the right one. So I say this is USB 1, I think, and written free log file .py should allow me to log everything that is written from the Arduino IDE to this thing. So it should be the exact same if I just type here, let's type thing, and it has received it, including a timestamp. So you get like all the timestamps. Let's say set this thing to 115200 baud. What else are typical messages? Please log everything you receive. So you can see me, I typed it here. Now it's logged into there, and it's written to a file. It's called logfile.txt. And if we now look at that file, I just exit this out by Ctrl-C, and then I just ls. We have a new file called logfile.txt. Let's open it. Cat log_file.txt. That's exactly what I typed just a moment ago. So you can see you can directly log files onto itself by looping it outside the system. So for the computer, it was exactly the same as if the data was coming from an external device. It can't make any difference. You could emulate this in software, but the setup is not as easy, and I don't think it works on any computer, and this thing does. And I can do the same with a thing that's not even like a full computer. I could run Python code on like an embedded system and do the same if I want to. So logging a device's output to a file, well, that's a feature that you can do internally on your computer, but it's not so easy from a different thing. So I use this to log stuff from Arduinos or other computers or Raspberry Pis or whatever. You just need a Blooper and a pair of USB-C cables, and you can do a lot more things with that. Back in the early 2000s, my means of transporting files from one computer to another was only select files that are below 1 megabyte or about 1.44, so I could fit them on a floppy disk and then put the files over. I even split files into more than, so I can put them onto multiple floppy disks. But that was very cumbersome, and I encountered that there was a product that allows you to transfer files from one PC to another over a USB port, which was brand new at the time, and we didn't really know if it would catch on, but USB was pretty promising, and USB sticks were crazy expensive back then. Another thing that was pretty popular back then was null-modem cables. These were basically UART cables, usually DB9 serial port cables that were used to connect two PCs together, and then you have a piece of software that exchanges data over them. And guess what? That still works on modern PCs, you just lost the serial port. But it's kinda hidden inside a USB protocol. So a USB port acts as a serial port, and you can still expose that functionality if you want. That is basically what the Blooper does. So once you have connected your cable at one computer and the cable to the other computer and join them in the middle with the Blooper, then both of these computers think they are the actual USB host. They both just talk to each other and everybody thinks he's in charge, but in reality they just exchange data like with a null-modem cable. So they can basically chat with each other. Hey, let's try that. Let's chat between two computers. And guess what? This also works if you plug both ends into the same computer, use different serial ports, then you can chat in a loop which is also very handy for debugging applications that you develop on your computer. With a null-modem cable, two devices just talk via UART. They just send raw data from RX to TX, from TX to RX. Usually that was a DB9 cable, and there are some DB25 ones, I think, so the serial cable. You also find that on some servers and industrial equipment. And it could also be done with a blooper, because in the middle between those two, that's a serial connection. That's standard UART. It just is converted from UART to USB on this end and as well on the other end. So they're both using USB ports, but they're actually talking UART. And if I now have like two windows open, and this one goes to USB 0, I think, and I've set the other one to use USB 1. Yeah, they're now connected. And if I type hello world, then it's received on the other one. I say, hello, you are another computer. I show you this, of course, on one computer, so you can see everything that goes in and out. It's just going over this external thing. But I could do exactly the same if I just plug in a laptop or stuff, but the screen capture would be a lot harder. But yeah, still works. Where is sending? Oh, watch element 14% for cool electronics projects and typos. I did mention I built the blooper myself. Yeah, here's KiCad and how it all works. Welcome to my schematics in KiCad. Pretty simple looking. This time we just have this thing here, which is a USB-C port, believe it or not. They just look like that. So this one is a USB-C port that only supports USB 2.0. It's missing some pins, but some pins that you don't find on a USB 2.0 port usually are these here, which are CC1 and CC2. You have to pull them down with 5.1 kilo ohms, so the powering works as expected. If you don't do that, you get weird behavior. We connect our data lines, of course, and our lines, but I also add a little Schottky diode on here. So if we connect both cables, they don't reverse power, which would in turn prompt the computer to shut off all power to the USB ports because it's getting an unexpected voltage and this could damage the port. So we have to have this diode, and then we have these FTX 230XS. These are FTDI USB UART chips. They can do a lot more, by the way, but these are really good because they always enumerate perfectly. They are easy resettable. They like to talk to each other, and they don't need any external crystals. And this is crucial because I don't want to mess with USB timing on this. I just want this to work. This has to be reliable and bootable at any time. Why don't I use any cheaper chip or so? Because they're not as reliable. So this is like when you're building a tool, you need it to work every time. So you need quality components that you can rely on. This is what this does. And we do it 2 times. So here's the other one, but we only use 2 LEDs because basically they are wired together. So one lights up when one sends, the other one when the other thing sends. So if you get a 2-way communication, both of them light up, nothing more. Important, we have a single reset switch for both. We need a 100K pull-up to that to VCIO, which has to have the same logic level voltage than all the other stuff, which is 3.3 volts, so we don't blow up things. And this 100K is pretty important so that there is a reset sequence for both of them. And that should enable us to communicate over this flawlessly. If you look at the board design, you can see Blooper on the back. And if you look at the layers, it's not that complicated of a layout. But do you see these points here? That's via stitching. That's important so we don't have any crosstalk on here. We need to have very good, very solid ground planes. Yeah. That's how I made this thing, and you can too, because you can download all the files for free on the Element 14 community. Assembly of the Blooper might be a bit fiddly because you have a lot of small components. I only need 2 LEDs, even though there are 4 input-output LED indicators, because they're both joined together, so I just use 2 differently colored LEDs to show which one currently issues traffic. That's all I need. A handful of passives, the UART to USB chips, of course, some USB-C ports, and I assembled the whole thing with my trusty pixel pump, which comes in as a godsend to these little fiddly jobs. I just had to do a little bit of rework for a bridge connection on the USB-C port. Be aware that if you have USB-C ports that have pins underneath them, if you want to use like the full range of USB 3.0 and 3.1 capabilities, then those bridges underneath might be really hard to rework. I usually flood it with flux and hope for the best. If you use USB-C ports that are only USB 2.0 enabled, like here, because there's no point in USB 3 something because the chips don't support it, then you can basically just look at it closely and see if there are any bridges. Make sure those are gone before you power it up first time, so you don't short out your device. For added protection against me goofing up, I've added a bit of heat shrink to this. It's just clear heat shrink, so you can still read the name and you can see the components, and also you can still press the button. So this is basically the absolute easiest way to make a case for a device that is just a simple PCB. And it's completely functional and compliant. So this is actually a good way to do it. Remember the weird cable I told you about in the beginning that I used to transfer files from one PC to another back in the day? Well, back then I had a USB stick that did hold 8 megabytes. And it was crazy expensive. It was slow and yeah. So before getting that, I bought this cable, which was like half the price or so, and because it worked in a very different way than a normal USB stick, it also was a lot cheaper. What I gather from how the software works and how it was to use it, basically you had to install software on both ends, and then it would read in some data, save it to a flash file on the cable in a little flash chip that was embedded, so it was basically a USB stick with 2 ends, and then the other computer would read back that. And they do it in rapid succession and reassemble the files on the receiving end. So you could get by with a lot less flash memory, and flash memory was very expensive back in the day, so this was overall a cheaper solution. And then, well, we all know what happens. USB sticks became ubiquitous and very cheap, and my device basically does a similar thing, but it doesn't even need a flash chip. Let's check out how it transfers files. Follow me to the computer. It's over there. No, wait, this time it's over there. Okay, now the third function that I want to show you is I'm transferring a file in binary code from one device to another. This is the same way that you would upload firmware over serial to some device. The way microcontrollers are flashed, some of them at least. The way big heavy industrial machinery gets new code on there. Or stuff is configured with like a UART device command. We just do this over USB. And for that, here's another app. I need file sender.py. This one sends the file. Oh yeah, you can't find it because it's Python 3, Python 3, file sender.py. And it says it has the file sent successfully. That's great and all. And you should see if I do this again. It blinked. It had actually sent all the data. The trouble is nobody has received that data. Welcome back. We have a new set of files, so we can finally do this. So I need to plug in my USB Looper again. So they should now be enumerated. And now I use Python 3 file reader.py. That one is listening now. Python 3 file sender.py, and we should see them communicate. It did send something. I just sent it again. Well, it did send. Let's see if it wrote to a file. There's a received messages.txt file and the received file.ext. Oh, I think that's a different one. Received messages.txt should be the one. Nano received underscore messages.txt. Oh, it's the log file that we did earlier. Ha ha ha. And it did it 2 times because, as you've just seen me, I've sent it 2 times. So now we have a way to just send a file from one PC to another over USB. The one thing that everybody told you not to do with like plugging in USB A to A type cable into 2 computers that could damage them. Well, now you can, at least if you have a blooper in the middle. One of the key advantages of basically faking that both ends are the host is you can emulate other devices. So I could pretend that I'm an Arduino, but I'm actually a guy typing on another computer to just feed data into a program that should receive data from an Arduino and see if the command parsing works right, for example. And also the other way around. I could have an Arduino on one end and it should send data to another Arduino, and then I would basically emulate that and give it the responses it expects, so I know that command handling would work. You can also use it to build custom protocols and whatever. So this is a very handy thing that I think a lot of my projects that you've seen previously on this show would not work out as good as they actually do. I basically used a very crude DIY version, and just now I've turned this into a thing that is like good enough to show on camera and looks like an actual thing you could use. As always, this project is completely open source. You can go to the Element 14 community page linked below to download all the files that you need and get the parts list and everything, so you can make your own. But do you have any tools that you made yourself to make your life easier? Or are there any problems that you need to be solved with a little tool? Maybe you have some ideas for future projects. Let me know. On the Element 14 community you can connect with me and all the other hosts, leave some ideas for future episodes. And I gotta go, there's another project waiting for me.